So in today's video, we're going to talk about the product and quotient rules. In this section, we're going to look at how to take the derivative of products and quotients. So the first one we have is the derivative of f times g of x. And then we're going to later on look at the quotient of f of x and g of x and take the derivative of that. Just for this one, I probably won't do it for the quotient, but for the product, I'm going to show you where this rule comes from. So just like before, if we don't know how to take the derivative of something, so we're going to ddx f of x times g of x, right? And so what I'm going to do is I'm going to use my limit definition of derivative just like before. So we have f of x plus h, times g of x plus h minus f of x g of x. So all I did was once again just plug in x plus h for the beginning, and then for the second half over here, I just rewrote the original f of x times g of x. Okay. Now what we're going to do next is kind of the, I guess, the key to the whole thing is we are going to take and we're going to basically add 0 to this problem. Okay, so we're going to add, so let me show you what I'm going to do. Limit as h approaches 0, and we're going to do f of x plus h times g of x plus, g of x plus h. And then we're going to subtract off g of x plus h, f of x, and then we're going to add g of x plus h times f of x, okay, and then minus f of x, g of x, okay, and all of this is still over h. Now I want you to notice that this right here and this g of x plus h f of x and this g of x plus h f of x, they're identical. Okay, and I subtracted one and added one. So if we add these two up, we get 0. So I basically added 0 or subtracted 0 to the problem. The reason this is important is whenever you add or subtract 0 to something, it should not change its value. So what we've done is we have not changed the value of the problem, but we've rewritten it. And the purpose of this is grouping. We want to regroup things now. So now we want to take the limit as h approaches 0. Now what I'm going to do is I'm going to move and I'm going to move the g of x plus h. You see this g of x plus h right here and this g of x plus h? I'm going to factor that out. So this is now going to become f of x plus h minus f of x, okay? And let me see here. I'm going to divide this by h. Then what I'm going to do is I'm going to put the factor. Remember, I factored out this g of x plus h. I'm going to put it right here. Now, how do I know I'm right? All I have to do is distribute this times this, and I will get back this original part, okay? And remember, this whole thing is divided by h, so this has division by h, this has division by h, this has division by h, and this has division by h. Okay, so it's not like putting the h here would be wrong, because if I were to re-split it, wouldn't it still be h divided to both of them? So I have done this correctly, okay? Now, I'm gonna add the other one, but this time notice that this piece has an f of x and this piece has an f of x. So this time I'm gonna factor out the f of x. So that's gonna leave me with gx plus h minus g of x all over h. And I'm gonna multiply this by f of x this time, okay? Now, this is all taken to the limit. So we have the limit of this, all right? So now what I can do is I can say the limit as h approaches 0. And remember, we're allowed to split a limit through multiplication or addition. So we're going to say of f of x plus h minus f of x all over h times the limit as h approaches 0 of g of x plus h plus the limit as h approaches 0 of g of x plus h minus g of x all over h times the limit as h approaches 0 of f of x. So what I did is I just took the limit of each piece of each product, and then so I took the limit of this times the limit of this plus the limit of this times the limit of this, okay? So no big deal, all right, just using our limit properties. Now this should look awfully familiar to you. What does that look an awful lot like? Well, isn't that the limit definition of the derivative of f of x? So this becomes f prime of x. Okay, now what does this become? This becomes, well, if I plug h in there, doesn't it just become g of x? Because it's the limit as h approaches 0. So plugging in 0 for h shouldn't do anything. I mean, in terms of, it won't affect the g of x. So this is going to be times g of x plus, now this should once again look familiar to you guys. This will become, this will become g prime of x. And then this will become, well, it has h approaching 0, but it's just of f of x, so it'll just become f of x. Okay, so we now have our final answer. Let me just rewrite it smaller. And that is that. Now, this is the way your book writes it. Normally, this is how I write it. I write f prime of x, g of x, plus f of x, g prime of x. As long as there's a g prime over here and an f prime over here, you're okay. I just like to always keep everything in the same position. If I'm doing the derivative of f here, then I rewrite f here. If I'm rewriting g here, then I'm going to do the derivative of g there and g prime it. But it's just a preference. This is how your book will do it, though. So just keep in mind whenever you see them talking about it. But both are correct answers. Okay, it's just a preference on how I like to write it. Okay, so now let's kind of see this in action. So this is the product rule. Okay, you know what, let me write it more formally. So product rule. Okay, so it says if you're going to take the derivative of f of x times g of x, then that will become f prime of x g of x plus g prime. They like to always have the derivative be the first thing. And this is our product rule. Okay, so make sure you learn that and memorize it. Okay, so now let's try an example. Okay, so find the derivative of, and then let's try y equals x squared plus 3x times e to the x plus 1. Okay, so now we don't have to FOIL this out like we used to before. Now we actually can take the derivative of this product. And I'm gonna, in the beginning, sometimes people like to also do this. They like to label this as u, I've seen a lot of instructors do this. They call this u and they call this v. So then the derivative would be u prime v plus, v prime u. That's a way you can do it much quicker. So I'm going to label this. This whole thing is going to be my u, and this whole thing is going to be my v. So if I find y prime, I have to take the derivative of u first, which would be 2x plus 3. That's my derivative. And then you have to rewrite. Notice it's a rewrite right here. You have to rewrite e to the x plus 1. So something really important about the product and the quotient rule is there are rewrites in the differentiation. You rewrite f of x or g of x, or u or v. Plus, now because I took the derivative of this guy first, I'm now going to rewrite that one. And I have not taken the derivative of this now, so that's going to be the derivative of e to the x is e to the x, and the derivative of 1 is 0. So that would be our answer. Okay, now we could FOIL that out and we could clean that up if you wanted, but I don't know if there'll be much cleanup involved. So for now, we'll say this is our answer, okay? But you may be asked to simplify as you go further in the process. So now let's say that h of t is equal to t squared e to the t. Okay, well, what we can do is we can then say h prime of t is equal to 2t e to the t. So I took the derivative of t squared, which was 2t. I rewrote e to the t. Now I'm going to take the derivative of e to the t, which is, oops, I'm going to do it my way, not the book's way. Now I'm going to rewrite t squared, and then what's the derivative of e to the t is e to the t. Now we could factor out a t e to the t, and that would leave us behind 2 plus t. So in this case, factoring helped a lot. It makes it look a lot simpler, a lot cleaner. Okay, let's look at another one. Okay, let's say we have z equals e to the w plus w squared. So take a minute, try to take the derivative of this one real quick, and then unpause the video and see if we get the same thing. Okay, so you guys should have unpaused the video. Let's see what we got. Z prime is equal to e, I'm going to take the derivative of this first function, EW plus 1, rewrite w squared, plus rewrite EW plus w, take the derivative of w squared, which is 2w. Now this one, there may be some cleanup, so I'm going to write this out. This is going to be, let's see here, w squared e to the w plus w squared plus 2wew plus 2w squared. So it looks like we can factor a w out at best. So this will be wew plus w plus 2ew plus 2w. I think that's it. Yeah, I don't see anything else that can be cleaned up. Oh, this w and this w. Yeah, so I could clean that up a little bit, I believe, unless I made a silly mistake. This would be wew plus 3w plus 2e to the w, okay? So as you can see, we still have to do a lot of factoring in algebra in our answers, okay? But that is the product rule, okay? So now let's take a look at the quotient rule. Now I'm not gonna go through and prove it, but it's done similarly, the quotient rule. The quotient rule says if you're going to take the derivative of f of x divided by g of x, then this will become f prime of x g of x. Now we have a minus g prime of x f of x, all divided by g of x quantity squared, okay? So this is the quotient rule. So let's see this one in action. Now this one, it really matters. You have to make sure that you take whatever the numerator is, that's the first derivative right here, because there's a minus sign, so now order matters. You must have the derivative of the numerator on the left side of the minus sign. So in this case, you got to be a little bit more careful. The product rule, because it's addition, we don't really care, you know, who you took the derivative of first, but with the quotient rule, you must take the derivative of the numerator first on the left side of the minus sign. Okay, so this is the quotient rule. So now let's try an example of this. Let's say that we have h of x equals x squared plus 3 all over 2x plus e to the x, okay? So then I'll say find h prime of x. So that means we have to take the derivative, and we get h prime of x is equal to the ddx of this quotient. So I'm going to follow the rule right here, and you could even write it like this. Once again, call this your u, call this your v. So this would be u prime v minus v prime u, and then this would be v squared. Okay, so that's another way you could look at it as well. So if we take the derivative of the numerator, x squared plus 3, that would just be 2x, okay? Then it says I have to rewrite the denominator. Then it says subtract g prime of x, so that's the derivative of the denominator, which would be 2 plus e to the x. Then it says rewrite the numerator, which is x squared plus 3. And then we divide it by the denominator squared, okay? So now, as you can see, there's probably going to be a little bit of cleanup here. So we have 4x squared 4x squared plus 2x e to the x minus, and now there's a lot of foiling here, so we have 2x squared plus 6 plus x squared e to the x plus 3e to the x all over 2x plus e to the x squared. Now, I don't know how much this is actually going to help, but I can see that this minus and this will cancel, and this will become 2x squared. And then let's see here, we have minus x squared e to the x minus 3e to the x minus 6 plus 2x e to the x all over 2x plus e to the x quantity squared. So really not much cleanup by foiling it out. It probably almost wasn't worth the effort. We can't factor an e to the x out. We can't factor an x out. We can't factor a 2 out. We can't factor a 3 out. So there's really not much left we can do. So I would say this is the answer, but I feel like this almost would have been fine unless they specifically asked me to simplify this. I feel like that might have been okay because the cleanup didn't really match what we needed. Okay, now they can also kind of fall back on, you know, something else. They might say find the equation of the tangent line to f of x equals e to the x over x plus 1 at x equals 1. So again, this is calculus code for if they ever ask you to find the equation of the tangent line, the first thing you have to do is find the derivative. So I need to find f prime because the derivative will help me find the slope of the tangent line. And this will become e to the x, so the derivative of the numerator, rewrite the denominator, minus rewrite the numerator, derivative of the denominator, which is 1. And then we have x plus 1 quantity squared, okay? So, and again, just for purposes, this is u and this is v. So I have u prime v minus u v prime. So as long as the left-hand side has the derivative of the numerator and the right-hand side of the minus sign has a derivative of the denominator, you're okay. And this is v squared. So now this can be cleaned up to be, let's factor out the e to the x, and let's see what's left standing. X plus 1 minus 1 all over x plus 1 quantity squared. So this would be e to the x times x all over x plus 1 quantity squared. Okay, so now we can find f prime of 1, and this would be e to the 1 times 1 all over 4, right? Because 1 plus 1 is 2, 2 squared is 4. So this becomes e over 4, okay? So that is the slope of the tangent line. Remember, this is my m, slope of my tangent line. So I also need to find my y coordinate. So I know that my x coordinate is 1. My y coordinate, I'm just going to plug into the original, and that would be e over 2. Okay, so then they want to know the tangent line. Okay, so I do y minus e over 2 equals m, which is e over 4 times x minus 1. And that would be the equation of the tangent line. Okay, and again, you guys, if you see a silly mistake, I'm not a video editor, so I don't go back, and if I make a mistake, I don't notice it. You got to let me know if you see it, and go ahead and shoot me an email. We'll figure something out. But in general, I feel like we're okay. I don't make a lot of mistakes in my videos. Sometimes typos, like I'll say one thing and write the other. But in general, it's pretty good. Okay. Okay, so now time for some practice, some harder ones. So combos. So combination problems. Let's just call it combo problems. Okay, so these are problems that have, you know, the product and the quotient rule happening at once, or more than one product rule. So one of the first ones I like to give students often is I say find d dx of x squared e to the x e to the x. Okay, so there's a couple ways you could do it, but we don't have the chain rule yet. So what we're going to do is we're going to treat, this is my u, this is my v, and this is my w. Okay, so I didn't give you the product rule for a triple product, but it works exactly the same. Okay, so what we're going to do is we're going to take the derivative of the first, which is 2x, and then rewrite v and w, plus, since I took the derivative of 2x last time, I'm going to rewrite it. The derivative of e to the x is e to the x, and then rewrite w, which is e to the x, plus x squared, rewrite, e to the x, rewrite, and then the derivative of e to the x is e to the x. Now we see that we have 2xe. Now, e to the x times e to the x is actually e to the 2x plus x squared e to the 2x plus, well, actually, I could add these up, right? This is x squared e to the 2x, and this is x squared e to the 2x. So this would be 2x squared e to the 2x. Now, what do they have in common? They have a 2, they have an x, and they have an e to the 2x in common. And that would leave behind 1 plus x. Yeah, sounds good. Okay, so this is how you can do a triple product if necessary. Now I'd like you guys to give this one a shot. So pause the video once I finish writing this down. X plus 1 all over x e to the x. So pause the video and give that one a shot and kind of think about what's messing this one up, what makes it a little bit harder than normal. Okay. All right, so hopefully you unpause the video and you realize that this is a problem that has the quotient rule and the product rule in the same problem. So what we're going to do is we're going to say, well, the derivative of the numerator is 1, right? And then rewrite the denominator, x e to the x, minus rewrite the numerator, which is x plus 1. But now I have to take the derivative of the denominator, and that's a product. So I have to use the product rule when I say take the derivative of the denominator. So that would be e to the x. So the derivative of x is 1, rewrite e to the x, plus rewrite x. What's the derivative of e to the x? E to the x. All divided by x e to the x quantity squared. Okay, so remember, I basically, when I did my product rule right here, I called this u and I called this v. So this is technically times 1, right? So that was my u prime v plus u times v prime. Okay, so I just did a little miniature product rule right here. Now let's do some cleanup. So this is going to be x e to the x. Oh geez, this is going to kind of be weird. If I factor this, this could be x plus 1, and then I factor out e to the x, and then that would leave behind 1 plus x all over x e to the x squared. You know what, I'm going to clean that up. That's actually going to be x squared e to the 2x, right? If I distribute that power to the x, e to the x. So now let's see what we got. So we now have e to the x factored out. So I basically went and factored e to the x from these two chunks. And that's going to be e to the x. And this will be x minus x plus 1 quantity squared all over x squared e to the 2x. Now I can FOIL that inside, and this would become x minus x squared plus 2x plus 1. All I did was FOIL it out over x squared e to the 2x. I can technically cancel this e to the x and this e to the 2x, and that would just become e to the x. And now let's see what we're left with. This would be negative x squared minus x minus 1 all over x squared e to the x. That's about as clean as it could get. Now, technically, this is your answer done with calculus. You are technically done here. So this is like your first step and you're done. However, a lot of the times they ask you to simplify and clean up. And then this would be, oops, this would be the simplified version of this, okay? So this would be your first step. And then all of this would be, you know, clean, 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 final cleaning, simplifying this quotient, okay? Let me see here. Oh, just a few notation that you may see. I don't know if this book uses the notation, but if you see f of g, or I'm sorry, not f of g, fg prime of a, this means d dx So take the derivative and then of f of x and g of x. So this is a way that they write a product quicker, evaluated at x equals a. Okay. Likewise, if you see f over g prime of a, this means take the derivative of the quotient f of x over g of x evaluated once again at x equals a. Okay. So in general, these are just shortcuts. I normally prefer to write it like this, you know, but sometimes you'll see it written the other way. But yeah, that's a pretty good start on the product and the quotient rule. Obviously, this is something that you need a lot of practice with, and we're going to continue to practice this. In the next sections, we're going to talk about sine, cosine, and tangent. Eventually, we're going to get to logarithms. So in general, definitely know your product and quotient rules. But they're kind of, you memorize them and then you just got to get comfortable using them repeatedly and make sure that you don't make up your own rules for math. Remember, you cannot differentiate a product piece by piece. You have to use the product rule, okay? And you can't differentiate a quotient, you know, numerator by denominator. You have to use the quotient rule for derivatives. So hopefully this will get you guys started on the homework. Let me know if you have any questions. See you in class.